Your Solana wallet is protected by a key, and that key has an expiration date, not a date on a calendar, a date set by how fast quantum computers improve. In April 2026, the Solana Foundation published its plan for that day. I built a site that walks through the whole thing in diagrams, and over the next 9 minutes, I'll show you around it. Chapter 2. Making a public key from a private key takes no time at all. Going backwards is impossible, and that one-way street is what protects your funds right now. But watch what happens when I switch this toggle to a future quantum computer. The return trip stops being impossible. It takes minutes. The algorithm that does it is Shor's, and ED25519, the scheme Solana signs with today, is one of the things it breaks. So how close is that? Here is what actually moved. Earlier estimates said breaking an elliptic curve needed around 10 million physical qubits. In March 2026, Google Quantum AI put it at under 500,000 in minutes. A neutral atom estimate goes lower still, around 26,000, though that one takes days rather than minutes. Note, the axis here is logarithmic. The machines didn't suddenly get bigger. The maths got cheaper. Now, the reality check. The largest number a real quantum computer has ever factored with Shor's algorithm is 21, 5 bits, and that was back in 2012. The target is a 256-bit curve. This grid shows the gap. 5 squares lit versus 256. Strictly speaking, those are two different problems, factoring and discrete logarithms. But the point is the difference in scale, and that distance is still enormous. Anza puts numbers on it. Within 2 to 3 years, essentially negligible. Within 5 years, 3 to 5%. That's small, but it used to be dismissed entirely, and now it isn't. That estimate assumes neutral atom progress keeps its current pace, so it will move in both directions as research runs. There's nothing you need to do today, it's just enough to start designing. And that is exactly why Solana is moving now. Chapter 3. What Falcon actually is. The name isn't the bird, it's an acronym, and it tells you exactly what the designers care about. First, Fourier transforms, which is where the speed comes from. Lattice over NTRU, which is where the security rests. And compact, because on a blockchain, every byte costs bandwidth. Worth knowing, Anza and Firedancer researched this independently, and both landed on Falcon. Security rests on lattices. Try this yourself. Which lattice point is closest to the red dot? Let me get it wrong first. And now the right one. In 2 dimensions, you barely have to think, but Falcon 512 works in 1024 dimensions. At that scale, nobody knows an efficient way to find the nearest point, not even a quantum computer. The price is size. A Falcon signature is about 10 times an ED25519-1. 666 bytes against 64, and the public key about 28 times. Together, that's over 1500 bytes, which doesn't fit inside today's transaction limit of 1232. That's why widening the limit to 4096 is the piece moving first. But here is a twist. Verification is actually faster than ED25519, about a quarter of the time. And that asymmetry is the whole reason Falcon with Solana. You produce a signature once on your own device. The network verifies it over and over. The heavy work sits on the side that happens least often. The catch is that the signing side is genuinely hard to implement correctly, which is also why its NIST standard is still in draft. Chapter 4 now, because this isn't just about your wallet. Elliptic curves live in 4 places inside Solana, and each one breaks differently. Accounts. The funds simply walk out. Programs. Forged signatures pass permission checks. Block propagation. Fake fragments float in and the network holds. Nothing is stolen there. Availability is what fails. And consensus. Two contradictory blocks both get finalized. That last one is a double spend, and it's the hardest of the 4 to fix. One thing was already safe, by the way, Solana's program-derived addresses, PDS. No private key is ever generated for them, so there's nothing for a quantum computer to break. But a quantum-safe vault doesn't cover everything. Move your assets into one, and the fee to open that vault still comes out of an ordinary wallet sitting outside. That wallet stays exposed, which brings us to Chapter 5, and honestly, the part I find genuinely clever. Let me step through this one slowly. An ED25519 key grows out of a 32-byte seeds through SHA 512. A quantum computer does break the elliptic curve and reach the signing value. So yes, funds can be stolen. But push further back and the SHA 512 wall throws the attack off. Hashes can't be reversed. The seed survives. And only the rightful owner knows that seed, so you prove you know it with the knowledge proof without ever handing the seed over and binding a new Falcon key to the very same account. About 400 kilobytes, 55 milliseconds, and you do it once. And your address, not a single character changes. Two things worth pointing out. This still works after Q-Day as long as you have the seed, and the attacker's recovered key becomes useless because Stage 2 switches ED25519 verification off across the whole network. Watch the shutter come down. The signature is still perfectly valid. There is simply no counter left to accept it. And this is where Bitcoin differs. Its earliest coins predate seed derivation entirely, so there is no seed to prove. Chapter 6. What's already running? This quantum-resistant vault has been live on Solana mainnet since January 2025. And it's built purely from hashes, which makes its security argument beautifully simple. Google's own paper cited it by name as a leading example. But there is a catch. Signing publishes about half of the private key. What these squares? So each vault is single use. Sign once, close it, move the assets to a fresh one. And where is everyone else? Algorand has run Falcon state proofs since 2022, though those secure proofs of history, not account balances. Ethereum plans to let each account choose its own signature scheme, targeting 2029. Tron is aiming for a quantum-resistant mainnet this year. Bitcoin has no binding agreement at all. But look at the right edge of this chart. Nobody has reached it. Everything lived today is opt-in. So, 3 things to take away. It's years off, but it's no longer zero. Your address never changes, and there is exactly one thing to do. Don't lose your seed phrase. Quantum computing gets used as material for fear a lot. What's actually happening is several teams quietly preparing for a day that hasn't arrived. The link is below. Go and have a look around. Thank you for watching. Bye.